Okay, so we are Clear Creek Solutions, obviously, and today it's going to be a real introductory workshop into WWHM-SWM, which is our flagship software. Like I said, I'll be letting a few people trickle in here as we go on. Our newest development in stormwater maintenance and managing. It's the combination of two real important things that we've been working on here, which is combining the hydraulic process and the hydrologic modeling process into one cohesive software package. And we've been working on this for a while. I did a video last month called "The Number One Stormwater Modeling Problem," and essentially what that video was covering is we're not able to model the entire cycle of the hydrologic, hydraulic, the entire modeling process in one piece of software. No one's really able to do that. We're sort of able to do it in some instances, but not to the degree of accuracy that we'd really prefer. And so what WWHM-SWM is attempting to do, and what we think does a really good job of, is combining that hydrologic and hydraulic process, so you don't need to leave the software to do anything additionally with your stormwater design process. Because if you're trying to use WWHM 2012 and then something else to model the hydraulic process, and then you have your own spreadsheets to do other calculations, and then you're also doing hand calcs with this, it's becoming real difficult to integrate all those processes into one, and you have it all scattered over these different things. There's no process to it. If one part of the project gets changed, you have to then go back to the other processes and make it work. And so we really wanted to have one tool where you could do everything that you wanted to. So a little background on Clear Creek Solutions. Okay, here we go. Some background on Clear Creek Solutions. Like I said, we provide a complete range of hydrologic and stormwater modeling services, and we've been around for doing that for over 20 years. The founding members have 40 plus years of experience. Most notably, we helped create the WWHM 2012, the Western Washington Hydrology Model, with conjunction with the Washington State Department of Ecology. And then we have developed similar software that's used up and down the West Coast and other parts of the country. And essentially the basis for that is continuous simulation hydrology, which is used in these areas to greater model the hydrologic cycle and then create stormwater detention facilities and solutions that will perform better in the future. And so we teach how to use those softwares as well as HSPF and versions of SWM as well. So let's get into WWHM-SWM. What is WWHM-SWM? Why is it called WWHM-SWM? Well, it's called WWHM-SWM because it's combining the power of WWHM, the power of SWM processes, APA SWM, etc. We're able to combine that into one software package, so hence the name WWHM-SWM, which is, of course, developed by us. And so we're able to take that process that we're able to do, such as modeling ponds and modeling LID facilities in WWHM 2012, and then combine that with the hydraulic processes of SWM, put it into one software package, and get it to work really well in one cohesive format. And so before we get into that, I'm going to assume that you don't know basically anything about WWHM-SWM, of course, and we're just going to get a basic overview, and then, of course, we're going to go into the software and learn what's going on and how that maybe can help our designs. So quickly, I'm going to go over what continuous simulation hydrology is. And unlike what we've learned before, which is something like single event hydrology, where we have a certain rainfall event occurring in a vacuum, which creates and produces a certain runoff. And that's sort of what we're taught early on in our hydrology education is, well, you have this land, it's a certain amount of acreage or miles, whatever. We have a 50, 10, 5-year, whatever rainfall event, and it produces this much runoff. And that's what we're kind of taught early on. That's not really how it works in the real world because it doesn't account for prior moisture conditions. It doesn't account for what is the storage of that soil. How's it going to run off? How are back-to-back events going to work? It doesn't account for anything like that. And so what HSPF was able to do, which was developed earlier in the 1970s, it's a software engine that uses something called continuous simulation hydrology, which allows us to model the entire process of the hydrologic cycle. And so HSPF is integrated into all of our WWHM and continuous simulation software. And so some of the benefits of using continuous simulation is we're able to gain more accurate hydrologic results and then a better understanding of what's going on in the hydrologic process. We get more accurate data we can more accurately model these facilities and gain a better picture of what's going on inside of our project. And so why is it important that we understand what continuous simulation is? You're like, I'm here to learn about WWHM-SWM. Well, because some people might say, well, some other software is able to do all of the stormwater functions as well. Like it can do hydraulics, it can do hydrologic processes. Yeah, technically, yes, but it's using single event hydrology, which is really not what we want to use when we want to get an accurate design. So it may claim that it can do multiple steps in the stormwater design process, but really it's not doing it well. And so we want to be able to do both well. That's really what's important. And that's what WWHM is able to do. And so with something like continuous simulation, we gain the ability to produce multi-year long-term records. We utilize the rainfall records to statistically evaluate runoff and stream flow in terms of magnitude, frequency, and duration. So we kind of need to look at this conceptual model here of WWHM-SWM, where we have the user input data for both HSPF, the SWM engine, and then there's different output files, the WDM for the HSPF, the SWM for the output file, and how they're both in congruence working in WWHM-SWM to create one cohesive result that you can look at and utilize in your stormwater design when we get into WWHM-SWM. And so some of the WWHM capabilities, and I did a WWHM workshop all the way back in March, and that's of course on our YouTube channel. You can view lots of information on that. But WWHM is the continuous simulation software. It uses HSPF, which runs in the background with that calibrated meteorological data, and HSPF is quite prestigious and has been sponsored and funded by the EPA and USGS. And so basically what we're trying to do is, using continuous simulation, we're able to model the entire hydrologic cycle, get that stormwater runoff, the surface runoff, plus the interflow most commonly, to produce the different flows that are occurring from off the site, but actually in a realistic way, because we're accounting for back-to-back storm events, infiltration, we're accounting for all the different soil types and how that's acting in usually a 15-minute time step, which is what's used in WWHM, and gaining a new idea, a new picture. Imagine if it's just like you had a computer screen, you're on a website and you were hitting refresh and that computer screen was updating. What continuous simulation able to do is it's able to hit refresh in a pretty short time span when it comes to hydrologic modeling and get a new idea of what's going on to increase our calculations. Something like single event hydrology. Imagine if you wanted to learn what was going on a website and you hit refresh like once a month, right? You're going to miss all those steps in between. You're going to miss a lot of what's going on. And so HSPF continuous simulation is what's used in WWHM 2012. And as I said before, it's using multiple year 15-minute historic rainfall data to generate that runoff data. And that is the engine that's being used in WWHM-SWM. Now, of course, it's going to depend on the location that you're using WWHM-SWM in, but for most who are using it in Western Washington, it's going to rely on that principle, and the same thing that you're going to see in WWHM 2012. So what's really brilliant is, if you're a WWHM 2012 user, you're going to easily transition to WWHM-SWM. It's going to be no problem because you're familiar with how that works. Yes, you'll need to learn how to model the hydraulic functions, of course, and then integrate that, but it's the same basic idea. And so WWHM uses continuous simulation hydrology to compute the pre-developed runoff, the post-developed runoff. We both understand that we then need to evaluate that, look at a flow frequency curve, and make sure it's meeting the flow duration standard for that. And so when we input a basin element into WWHM, the drainage areas are divided into the pervious land segments based on the soil, vegetation, and land slope. And then the pervious and impervious segments are then linked to conveyance pathways such as pipes, ditches, and ponds. And then really in WWHM-SWM, a real big emphasis on pipes, of course, because now we have swim elements that we're able to use with it. And then historic rainfall and evaporation are then used as input for that. And so the entire water cycle is modeled on a 15-minute or shorter time step for multiple years, and so we're able to gain an accurate picture of what's going on the project site. And it generates three types of runoff from that: surface runoff, an interflow, and then a groundwater or base flow. And so what we do in WWHM is we locate our project location on the map. We input a pre and post-developed land use, and then our proposed mitigation measures, whether that's LID, whether that's bioretention, whether it's a detention pond, a storage vault, a commercial element, doesn't matter. We're able to put that in the software, model that situation, see if we meet the flow duration or the local jurisdiction requirements, no matter how many minimum requirements we're trying to meet. And then we're able to analyze that at a point of compliance and then view, is that facility working? What adjustments do we need to make? That's the basis behind WWHM. Now, before, there was no hydraulic modeling process at all in WWHM. That's not the purpose of WWHM 2012. WWHM, we finally bring that into the forefront and now are able to do that. And so the Western Washington, the Department of Ecology Stormwater Management Manual, as many of you are probably familiar with at this point, specifies a specific flow duration, as I mentioned before, and requires the use of the Western Washington hydrology model to, or an equivalent, to evaluate that flow duration and make sure we're meeting it for that project site. And so the flow control standard, it's based off the erosive flows that are created. So we have identified the erosive flow range as half of the 2-year all the way up to the 50-year flow. And so if we're exceeding flows in that range, that's where really we're starting to cause problems with our project site, right? Because if we have a forested area, there is some erosion, but it's naturally occurring. The local environment's used to it. But if we then add a bunch of impervious areas, some houses, some buildings, and now we have much more runoff, we're going to surpass those erosive flow range quite a bit more, causing more erosion and causing more problems in the local ecosystem and our streams. So we need to create detention measures to make sure we can match that pre-developed flow. And then in that way, we're able to simulate the pre-developed condition and not cause harm to the environment, and of course, meet the minimum requirements that we're supposed to meet. And so this is actually screenshots from WWHM now. So this is just showing you that WWHM can do the same thing WWHM 2012 can, and then even better because there's just more options available. But this graph here shows you for the flow duration analysis, the percent of time the flow exceeds specific value. The red line is below that blue line, which the red is the mitigated flow. The blue is the pre-developed flow. So it's not exceeding that flow range. And so our facility, whatever we have here, it's likely I auto-sized a pond or something like that. Whatever facility we're using, it's now meeting that requirement and will be good to go for the stormwater portion of our engineering design, whatever you're doing on the project site. But this requires continuous simulation. And so other software that you may think, oh, this can do hydraulic calculations, this can do my pipe sizing or whatever function. But can it do continuous simulation hydrology to compute the flow duration? Probably not, and probably not well, and probably not quickly, and probably not in a way that you're familiar with. And so this is what makes it really easy to then integrate the entire project process into one. Now you're doing everything in one software as opposed to multiple things, or not being able to trust the results from one, not sure where you're ending up. You will know that this will work for you. And so it's the stream protection duration. It's minimum requirement number 7, which is the flow control standard, half the 2-year up to the 50-year flow is that erosive flow control range. And so you can see the facility passed on the right of the screenshot there. So what are the WWHM basic elements? As you can see, they look a little different now. We updated the graphics for WWHM. Looks a lot better. Should be a lot more enjoyable to use from a user interface standpoint. That was a big part of our development of the software. We wanted to sort of get the feedback from people of what they thought about WWHM 2012 and other ways of doing stormwater modeling. And we did a lot of testing on making sure it works smoothly for people. They like the way it looks and they're able to build projects quickly. And then, of course, we've done, at this point, years or close to half a decade of in-house testing, making sure that it works appropriately. So we have, starting from the top left and going down, we have the land use basin, then the new trapezoidal pond, a tank, lateral pervious basin, the vault. We've got our open channel still. All the elements that you see in WWHM, they are here. They just have some new icons. They just got a little bit of a refurbished look for the 2020s, of course. And then, of course, we have the LID elements, bioretention included right there, green roof, permeable pavement, the compost amended vegetated filter strip, culvert. We still have that swim connection element, but you're going to be wanting to use swim elements from now on and the hydraulics element. So all of those are included. They're right there. And then, of course, you can enable commercial elements once again in WWHM. You'll just have to follow the same process that you did for WWHM 2012, but those are also all available. I'll be able to show you those in the schematic.